Hello and welcome to this presentation from Maidenhead Bridge. In this video, we're going to present the cloud security connectors with private cloud private access and advanced NAT gateway for AWS, Microsoft Azure, Google Cloud, and hypervisors for on-prem, VMware, KVM, or Hyper-V. A quick introduction about Maidenhead Bridge. Maidenhead Bridge is an independent software vendor company in the emerging category of multi-cloud network software providers. And we enable customers to connect to secure service edge and cloud-to-cloud communications. Our company is inspired by the mantra of Unix: do one thing and do it well. Create one product that works well for the environment and the purpose that is designed. It's not a multi feature that has our products are not multi-feature products that have a lot of things that no one works well. We design specific things to put the correct device to keep your company up and running and secure all time. Maidenhead Bridge was founded in 2016. We are based in England and we started helping customers to connect to Zscaler and Netscope Cloud, both Gartner leaders. In response to customer demands, because to connect to Zscaler and Netscope was the objective was to protect the public traffic going to the internet from customers. But in response to customer demands, the company developed an innovative technology called private cloud private access, which simplifies and secures cloud-to-cloud, site-to-cloud, and site-to-site networking. Maidenhead Bridge has more than 300 customers worldwide. And I am Adrian Larsen. I was member of the first Zscaler SC team in 2009, and I found that Maidenhead Bridge in 2016 to solve the challenge when connecting to SSC vendors from public clouds, AWS, Azure, G-Cloud, and also on-prem. Also, I was part of several startups in the past, like Force System acquired by Marconi, ArrowPoint System acquired by Cisco, Ironport System acquired by Cisco again. There was Cisco employee twice. And Zscaler, Nimbula, Certes Network, multiple startups during the last years before to create my own company to help Zscaler customers mainly. Let's talk about the private this private cloud private access, what it is. Private cloud private access is a cloud native solution for WAN communications that cover the scenarios of site-to-site, site-to-cloud, and cloud-to-cloud, following the principles of zero trust. Now, with private cloud private access, you can easily create a full mesh communications with zero trust. Why private cloud private access is needed? Well, the main reason is legacy security networking solutions cannot be forklifted to the cloud. There are technical, operational, and security limitations when using legacy solutions. Networking engineers like me in the past designed legacy networking solutions to communicate branches, central offices, and data centers. Cloud communications arrived with new challenge of networking security and mainly operational agility. We cannot throw commands anymore. We cannot do GUIs. This all need to be DevOps. Applications are now distributed in multiple VNet VPCs of different clouds. We need any-to-any communications. APIs are required to be accessed from numerous sites. You need to protect the APIs and all of this traffic. And we still need to communicate with on-prem services. Then what we need here is an agile method of any-to-any secure encrypted communications with zero trust. And private cloud is the answer to this challenge. Let's explore what the cloud offers to you today if you want to connect to them. Well, all clouds has created some kind of product or adapted product or some, I don't know how to call it, that allows you to use your legacy infrastructure and to connect to the cloud. And And the solutions are multiple. You can use VPN gateways, Direct Connect, Cloud One, Cloud Firewall, Private Link, NAT Gateway, Virtual One, MPLS, Network Connectivity Disaster, Private Service Connect, Cloud Connectivity. This is all names of cloud solutions to connect your company to them. But the truth is, cloud networking has failed because too many pinpoint separate solutions. You can't do a multi-cloud aggregation or to connect multiple sites without to deal with each one that is proprietary and is complex to set up, and you need to deal with the other one, and multiple offerings, multiple pinpoint solutions doesn't help. And the Cloud Security Connector is the ultimate solution, effectively replacing all options mentioned here. Let's take a look about the problem. How is the evolution of the private traffic when you need to connect a cloud hybrid environment? Well, in general, you will find different solutions. We mentioned a lot of them in the previous slide, but the most common, probably the only one who you can really apply when you have multiple environments is to use VPN gateways and BGP. And here we have an environment with cloud, Azure, two regions of AWS, and two on-prem data centers. And the benefit of this solution is all traffic is encrypted and all protocols are supported. Then you can use all foreign protocol here. There is no limitation that some kind of the services. But the drawbacks of this solution is first things first. The VPN gateway are very expensive, and the price is difficult to predict because they cost you per tunnel, per VPN type, per bandwidth, multiple things, and you don't know how much it will cost this. The second problem, and this is the technical difficulty of this, is the lack of scalability, because if you want to connect, for example, 10 sites, you will need to do, and in full mesh, you need to do 90 tunnels. The formula here is n times n minus 1. You will require to create 90 tunnels to create a full mesh environment for your organization. That the truth is you're not going to do it. Doesn't work, doesn't scale. And of course, it's extremely complex to set up because it's one configuration for Google Cloud, another for Azure, another for AWS, and another for your firewalls. Then you need to have knowledge of multiple things, multiple clouds, multiple firewalls, and how to interconnect each one. And on top of this, if you want to route to have some intelligence that this machine can discover this, you need to implement BGP inside. That it will be very complex to do BGP having 90 places. It's like creating an ISP for 90 places. It's crazy. It's impossible really to implement. What is the benefit of the Cloud Security Connector? Instead of using VPN gateways, put a Cloud Security Connector on each cloud and on-prem. The connector has intelligence to create what we call the private cloud, and we use a technology that is called crypto key routing, that it doesn't do the tunnels in advance, and the connector has the intelligence that when these machines want to connect this instance, for example, to create the secure connection with crypto key routing, that is packet per packet encryption. The beauty of this, number one, is you don't need to do any tunnel here. Moreover, you don't need to have any networking knowledge to do this. You only need to know about IP, subnets, protocol, and port. That's it. If you have knowledge about this, you don't need to know APSec, you don't need to know anything else. The connector will create the full mesh for you. You don't need to set up any tunnel in advance using crypto key routing. And also the connector will do the zero trust because you can set up rules saying this machine can talk with this instance in port TCP22, but and it's the only communication that this machine can do. The machine cannot scan the other one or to go to the other one. Then you have a full firewall around your each site. And its extremely benefits are clear, visible. Number one, there is an extreme savings. It's almost 80% savings comparing with VPN gateways. And here the price is predictable because you pay as you go per connector on each side. Then it's no per user, no per tunnels, nothing. You know this will cost this amount of money and that's it. And you can put as much traffic as you want or users. Benefit any-to-any communications. All traffic is encrypted. All protocols are supported. It's scalable. You can add multiple sites and you can create multiple clouds in your environment as well. It is zero trust, as I said. You can create policies saying this machine can talk with this one important protocol, no, with the other one. Uh, Everything is networking as a code. Okay, something modern according to DevOps, according to make something uniform, right? And extremely easy to do. With a single JSON file, you will be able to control all your private PriCPA cloud with all the zero trust communications in a single file, period. You have the definition of the site, you need to tell the subnets behind, and you can create the rules, policy rules after. Uh, all deployment is automated in all clouds using CloudFormation or Terraform or Azure Resource Manager. There is visibility traffic end to end. This is important as well because several solutions are not providing um, the visibility of the traffic end to end. Then this device, this instance, will receive the logs, and on this instance, you will see that the source IP is this machine. End to end IP communications are clear and direct. Traffic log, of course, the solution provides traffic log that you can see all the traffic inside the cloud. Blocks lateral movement, and we say zero trust. This machine can talk with this, but not the other one, and this machine will not be able to scan here. And it's high performance, minimum, it will provide you 1 gig per site, depending the instance you are using. But let's talk about the architecture in general, how easy or how difficult it is to create this um, private cloud, private access. It's extremely simple. You need to know 3 values: the public IP of the site, the subnets behind the site, and each node has a private IP of the PriCPA cloud. Each node is identified with its own IP. Okay, then this is the only thing you need to do. If you need to be an architect here, you need to know IP, public IP, subnet behind, and node IP. And how this works? What is the magic here? When this machine in this subnet behind wants to talk with this instance in, I don't know, 10.1.5, 101, whatever it is here, then it start the communication. This node will say, okay, this subnet 10.1.5 is behind this public IP. Then this node will initiate a communication to this node. And here is the exchange of keys and the creation of communication on the fly. You don't need to do in advance. And after this node will allow to communicate with this 10.1.5. Then with 3 values, you are creating a full mesh communication for your company that is uniform to all sites. You don't need to know BGP, you don't know to know IPsec, you don't need to create anything in advance. And moreover, everything is automated. For example, if I add a new node, my cloud, or here another cloud, when I send this single JSON file with all the communication, the new node creates automatically all security groups in the cloud. Then as soon as you add a new node, this node will talk via the API. I will create the new security groups. And if you deploy a new one, also when you deploy a new one via Terraform or CloudFormation or Azure Resource Manager, the deployment creates automatically your IP, your security groups, they know everything. Everything is done automatically. Then it's very little effort. You can create a full mesh zero trust encrypted network for your company. How is the configuration? It's two steps configuration. Number one, you need to go to the node and to create a local configuration. Also, this configuration can be created automatically at the moment of the setup. But in this local configuration, you can see here there is a node name, location, description, and the public and private keys is created. Okay. And also on this first communication, the public IP of the node and the private IP of the node, the ID of the node, that is the IP of the PriCPA cloud. With this information, you need to copy and paste from node name to private apps. You go to the peer.json file. On the peer.json file, you copy the local configuration, and on the segment networks, you need to put the networks behind the node. And after, the private apps. For example, in this case, I have the subnet 10.2.4 something. I say to this server 10.2.4.4, I will allow TCP port 22 and 33 RDP and SSH from my management networks. Okay, then, and now this you need to do this local configuration, subnet behind, and private apps for all nodes and distribute to each node and reload. And each connector will create a communication for the new node, will apply the routing and because it knows the networks behind each side and will create the security rules. In terms of security rules, it's extremely intelligent because when you do security rules in general and you have firewall, if you want to connect this laptop with this instance, well, in this firewall you need to do a communication to this way, and in this firewall you need to allow the opposite, right? You need to go to two places. In using PriCPA, this problem doesn't exist. The single JSON file will hit this node, and both will create the rules for zero trust communications in a single shot. The next functionality of the Cloud Security Connector is the replacement of NAT gateways. When you do communications on cloud, you need to communicate your private traffic between sites, but also you need to allow your servers to go to the internet. And for example, you have a Ubuntu server and you need the Ubuntu server to go to the internet for I don't know, repositories to update the software, or you need to reach another site via the public internet and not private internet for some reason. Then uh, when you want to communicate instance in the cloud to the outside world, what the clouds offer you are NAT gateways. Then you have the NAT gateways. The benefit of the NAT gateway is a simple NAT. It's something really simple. But the drawback is, well, it costs money, of course. And it's not with firewall rules. Doesn't exist to create firewall rules here. And you need to create firewall rules for the instance, or for the network application, or security groups, or firewall rules here on called in Google Cloud. Then it is extremely frustrating because if you have multi-cloud environment, it's one set of cloud rules here, another for Azure, another here, another for the firewall. It's very complex when you need to use this outbound firewall functionality in multiple environments. In the case of the connector, this functionality is with the connector. Then if you go to public traffic, not private, um, just the same connector for PriCPA, you will be able to create, to use as a NAT gateway, and also to create why we called advanced NAT gateway, because you create outbound firewall rules as well. Then you can create rules and say this instance source IP will allow to go to this place via public IP in that port and protocol only. It's not a NAT gateway that NATs everything without rules. No. In this case, it's a specific communication, source IP, destination IP, protocol, and port. And the benefit here, the clear benefit is First, it's free, right? It comes with the product, and it's no extra cost to use the NAT gateway. And then you can replace VPNs, gateways, and NAT gateways with this product. The next benefit is you have rules, firewall rules. Then you can have a way to configure a uniform policy with the same way to do configurations in all places. Doesn't matter if you're on Azure, on AWS, on Google Cloud, or on-prem. You have the same way to configure. Uh, a configuration is as a code. Again, it's a single JSON file that you distribute to all nodes, and then you have the intelligence to create the policies on each site for outbound traffic. Extremely simple. Then, with the connector, we can create rules. For example, uh, we want to reach Office 365 endpoints from everywhere in your cloud and your environment. Say, okay, from anything, any source IP, TCP. This is the destination of the rule for 8443. Extremely simple. Everyone can understand this. As I said, you don't need to have any knowledge on security, networking, or security except IP subnet protocol and port. And you will be able to create a full mesh network for your private traffic and replacing the VPN gateways. And here with the NAT gateway functionality, you can replace the NAT gateway with the add-on that you can create policies, outbound policies, and not allowing any to any. Okay, this is the view of the Cloud Security Connector PriCPA in high availability in Google Cloud, in AWS. What happened in high availability? If you want to deploy in high availability, in this case, you need to deploy a connector on availability zones, different availability zones. And the connector is active-passive configuration, and the connector will manage the routes for all internal instance. It is done automatically. You need to specify the routes and say, this route, we use this target as a net hub, because this is the IP of the connector. And if this connector is active and goes down, the other connector will detect, okay, this is not active anymore. Then I will move all routes behind via this connector. And also moves the IP, the public IP from this device to this device. It's on automatically via the control of the AWS API. Then you don't need to do anything. This, in the case of high availability, the high availability is provided and automatically. It's the same on Azure. In Azure, you can deploy to the connectors, always active passive, and the connectors can be on availability set or availability zones. The connector will do the same job. In the case this connector is active and it goes down, the other connector will read, okay, this is not working anymore. Sorry. And then I will change all internal routes and I will set up the next hop, my IP for that route. It's automatically, you don't need to put extra devices like load balancer or extra functionalities. Nothing. The connector via the Azure API will do the job. Same for Google Cloud. In this case, in Google Cloud, you need to create a setup, this setup with some extra VPCs, but this is a design of Google Cloud. And when you have a Google Cloud, when you have a device with multiple interface, you need to put each interface in different VPC. That's the cloud, I don't know, called limitation of feature, but this is what it is. Then in this case, we need to create these three VPCs, the internals and the two external for the connector. And same than before, high availability, active passive, if this goes down, this will via Cloud CLI will move the gateway via this connector. On-prem, also there is a high availability. On-prem, this case is a Linux cluster, active passive again, but the gateway will move from one device to another when the connector is down. In terms of deployment, management, and monitoring, I say before, This is all the working as a code, and this is DevOps oriented. Then you can deploy using DevOps tools, and you can manage using DevOps tools. In terms of deployment, you can use Terraform, CloudFormation, or Microsoft Azure. In case of change management, when you want to update rules or you want to change rules, all change management is done via any tool that does SSH, has SSH access to the device or a client. Uh, like AWS System Manager, we love AWS System Manager. We recommend to use AWS System Manager. It's extremely powerful tool, and it allows to control the connector from the AWS cloud worldwide, or Rundeck or Ansible or any tool with, that provides change management. In terms of troubleshooting, if you want to see, have visibility, what's going on, all connectors has TCP DAM in, inside. Then you can check source IP, destination IP, protocol, and port, what's going on with the communication. Admin access, you can do multi-factor authentication, of course, if you want to access to the SSH console. Log collection, the connector provide logs for traffic logs and system logs, up, down, change in that particular configuration. All the system logs are available, also all traffic logs. And if you want to see statistics of traffic, you can use SNMP, or the connector has also a bandwidth monitor that you can get into the console of the connector and see how much bandwidth are you using. That will provide you statuses, statistics, and real-time traffic. Well, this is the end of the presentation. I hope you enjoy the presentation. Please don't hesitate to contact me directly, alarsen at maidenheadbridge.com, or our sales team, sales@maidenheadbridge.com, our website, and our support information. Thank you very much for your time. Remember, with the Cloud Security Connector, with PriCPA and Advanced NAT Gateway, you can do a full mesh network, scalable, encrypted, and zero trust among all sites and clouds. And with the NAT Gateway, you can replace the NAT Gateway in the cloud, and to add a uniform outbound firewall policy for all your sites. Thank you very much and have a good day.